Hi, let's give an overview of standard form categorical propositions in the modern square of opposition in as close to 5 minutes or under as we possibly can. The main, overall, most important concept touched on in chapter 4 is the notion of the categorical proposition in general. So first, we learned about 4 forms of standard categorical proposition. The first is the form all S are P. And in this situation, and notice in this Venn diagram, shading means that region of the Venn diagram is empty. So if all S's are P, then the region that has S but not P is empty. All S are P is considered an A statement, and it's a universal claim, and it's an affirmative claim because all S are P. An E statement shades the intersection of S and P because there's nothing in the overlap of S and P. This is also a universal claim, but it's making a negative statement. The third kind of standard form categorical proposition is the I form. The X in the Venn diagram indicates that there is at least one thing in that region of the Venn diagram. So if some S are P, there is at least one thing in that region, and it's particular. That's why we use an X instead of using shading, and it's affirmative, so there is something there. In an O claim, we say that some S are not P, and this means there's at least one thing in the region that has S but not overlapped with P. This is also a particular claim, and it's making a negative statement about what is not P. So those are the 4 kinds of categorical proposition in standard form: A, E, I, and O. So it's important to commit these to memory. It's going to be really useful for learning about logical relations between these types of statements. The next important concept covered in this chapter is the concept of distribution, which means that the claim makes a statement about every member of a particular term. So A claims distribute the S, E claims distribute both S and P, I claims distribute neither, and O claims distribute the P. So return to the textbook to get more details on what distribution means, but you can also just try to memorize which terms are distributed. The next important notion went over in this chapter is the modern square of opposition. This is distinguished from the traditional square of opposition, which we'll get to later. The modern square of opposition refers to logical relationships between these claims. So A and O claims, as well as I and E claims, have a particular logical relationship, which is the contradictory relationship. This means that if an A claim is true, then the corresponding O claim that has the same S and P has to be false, and so too with an I claim and an E claim. So let's look at an example to see why. Take an A claim: all movie stars are famous. That's true, and that is an A claim. The conclusion here, therefore, it is false that some movie stars are not famous. Is this a valid argument? Let's look at the Venn diagrams for each of these statements. First, let's symbolize them. Premise 1 says all M are F. The conclusion, let's diagram all M are F first. So all M are F is going to mean the M region that's not F is going to be shaded because that region is going to be empty. Okay, what's happening in premise 2? It's saying the claim is false that some movie stars are not famous. So what does the claim that some movie stars are not famous look like on a Venn diagram? The claim that some movie stars are not famous looks like an X in the region that has M that's not F, right? So here this conclusion is saying that state of affairs in this Venn diagram is false, which would mean that that region, instead of having at least one member, does not have at least one member. In other words, it's empty. So since those 2 Venn diagrams are equivalent, that means that the conclusion here does follow from the premise. That's because we have an A claim and an corresponding O claim, which are contradictory. So since the A claim is true, the O claim, which would say that some movie stars are not famous, the O claim has to be false since the A claim is true. And if you substitute in anything for those claims, then the same is going to hold. There you have it, a very, very quick introduction to standard form categorical propositions and the modern square of opposition. I encourage you to work through more examples, and I'm happy to talk about it more or make more videos with more examples if that would be helpful. So please let me know.